Hello, ladies and gentlemen. Today we are covering section 10.5a, so the first half of 10.5, and this is about angles that are related to a circle. The other half of section 10.5a is also about angles related to a circle, but there's so much content in here that we wanted to break it in half to make sure that you have a good idea of what's going on in all of them. So first of all, we're going to do some defining of a couple different kinds of angles that we can make in a circle. And then we're going to talk about how to measure them and what they can be used for. So the first one is one we've already defined twice. It's a central angle. And this is important, these headings. This is an angle that has a vertex at the center of a circle. So that's what we can say. It's an angle with a vertex at the center. And actually, it already says angles with vertex at center. So we'll say it's an angle made of two radii. So from the center to the edge, we can make one radius and another radius, and we've created a central angle with its vertex right here at the center. And then for examples of how to measure these, they're just measured by the same measurement as the inner angle. Well, the inner angle and the outer arc. So if this inner angle is 80 degrees, its outer arc is also 80 degrees. So when an angle has a vertex at the center, its angle and arc measurements are the same. What you'll see today is that's not always true. Sometimes we have angles with their vertices on a circle, and one of them is an inscribed angle, which we've already talked about a little bit. An inscribed angle has its vertex on the circle, but its legs go out to the edges of the circle. So we're going to say it's an angle with a vertex on the edge of the circle and legs in a circle. So it's got legs in a circle. And you notice that it's under the heading of angles with their vertices on a circle or on the edge of a circle. In an inscribed angle, which has its vertex on the edge of a circle, if we were to create one and compare the measurements of the vertex where the angle is and the measurement of the arc that that angle cuts off, they would be different. If our angle was 30 degrees, it would cut a 60-degree arc on the circle. So if we have an inscribed angle, it doubles between the angle measurement and the arc measurement because we're measuring from all the way across the circle and not just from halfway across the circle. A tangent chord angle is another one. And for a tangent chord angle, it's made up, like it would suggest, of a tangent and a chord. So if we draw a chord in our circle, and then wherever that chord ends, we create a tangent line going out. So this is part of that tangent line, like that. That would be a tangent chord angle. So here we'll say it's got one leg inside and one leg tangent to the circle. So one leg inside and one leg tangent to the circle. And as we measure these tangent chord angles, sorry, you couldn't even see that. As we measure these tangent chord angles, it's going to have the same pattern as an inscribed angle. So maybe I have a chord that goes like this, and maybe I have the tangent coming off this way. And in this tangent chord angle, maybe my angle is 75 degrees. But then the arc that it cuts off right here, that's the arc that's cut by the angle, that would be a 150-degree arc. It would double. So out of the 360 degrees in the circle, 150 of them are taken up by just that arc. So here's a summary. We're going to do 2 of these today and 2 of these tomorrow. Today we did the vertex at the center and vertex on the circle. Those are these kinds of angles we looked at today. So if you have an angle with a vertex at the center, the angle measurement is equal to the arc measurement, like we did up here with a central angle. If you have a vertex on the circle in your angle, as in inscribed angles or tangent chord angles, then the angle measurement is half of what the arc measurement will be. So that would be with inscribed and tangent chord angles. So always based on where the vertex is how we measure these angles. The next two we'll do tomorrow, but today we're going to work with inscribed angles and tangent chord angles mostly. So coming down here, we're going to do some examples. Here it says determine whether each angle is an inscribed angle. If it is an inscribed angle, name the intercepted arc. If it is not an inscribed angle, tell why. So AC, it is an inscribed angle. It has its vertex at the edge, and it goes out with its legs to the edge of the circle. So yes. And it says name the intercepted arc. So this arc intercepts arc AC right there. That's where the angle opens. We can call that arc AC with just an arc over the top. This is not an inscribed angle, all right? And the reason it's not an inscribed angle is because its vertex is not on the edge of the circle. So vertex, not on edge. All right, and this last one is also not an inscribed angle because it has a leg out. In an inscribed angle, both legs need to be in the circle. This leg is outside the circle, so no. And it's got one leg out of the circle. All right, so let's do some measurement problems here. We've got some angle measures, and it says use the circle below. So this is all showing how an angle is going to interact with the arc that it cuts, all right, with the arc that's created by the legs of that angle. So this one says the measure of arc AB is 60. And if the measure of arc AB is 60, then the measure of angle C is what? And if we make AB 60, the legs of angle C come to A and B, which means that 60 is the arc cut by this angle. That means that because this is an inscribed angle, it's got its vertex on an edge, the angle measurement is going to be half as much. So it's going to be 60 degrees. Or sorry, it's going to be 30 degrees. Angle D opens onto the same arc. It's got a different point, but it opens onto the same arc. And that means that angle D is also 30 degrees because its arc is 60. So it will have half the arc as its angle measure. Here's a different scenario, so we're going to cross this off. If the measure of angle D equals 22, so if angle D is 22 degrees, then the measure of arc AB is what? So if angle D is 22 degrees, it opens onto arc AB, which means that arc AB is going to have to be double of 22. So it's going to be 44. And then the measure of angle C. Well, if this is 22, it sort of projects a 44-degree arc onto the edge of the circle. That means that 44 out of the 360 degrees of the circle are right here. And if this is a 44-degree arc, then the measure of angle C is going to be half that measure because it's an inscribed angle, so it will be 22 degrees again. In the next example, it says the measure of arc DB is 45 degrees. So if the measure of arc DB is 45 degrees, it wants us to find the measure of angle DAB. Well, DAB is an inscribed angle that opens up onto this arc, which means it's going to have a measure of half of 45 degrees, or 22.5 degrees. Then it asks about CD, and it says C is the center of the circle. We can see because it's got that little circle right there that happens when we have the center. So if C is the center, angle DCB is a central angle. And we know from the front page that if an angle has its vertex at the center, then its measure for the angle is the same as the measure of the arc that it cuts. So if there's a 45-degree arc created by angle DCB, then there's a 45-degree angle right there as well. All right, a couple more here. Let me get some water real quick. So here we have what's called a tangent chord angle. Given FE is tangent at E, so there's our tangent line. The measure of arc DE is 80. So this arc right here is 80. Find the measure of angle DEF. Well, a tangent chord angle is another example of an angle with a vertex on the edge of the circle. So this angle, even though it goes outside of the circle with one of its legs, the vertex is on the edge. And the rule about vertexes on the edge is that the arc that they cut is twice as much as the angle measure of that angle. So the angle FED is only going to be half of 80, which is going to be 40 degrees. So the measure of angle DEF equals 40 degrees. All right, and last one, this one's got a lot going on here, so we'll think about what we can do. It says, find all remaining arcs and angle measures in the circle. If you wanted to, you could turn the video off for a second and see how far you can get on this problem without me telling you what to do. And then I'll explain how you should go about this. So to find all the remaining arcs and angle measures in this circle, what I'm going to think about first is I see that I have 58 and 106 right here. And if I add 58 and 106 together, that gives me 164. Okay? So this arc, this big arc, is 164. If you look at angle X is an inscribed angle that opens onto a 164 degree arc. So angle X is going to be half of 164. So it's going to be 82 degrees. All right, so then we can think, all right, what can I do next? Well, now I see that I have 93 here. 93 degree angle is going to open up onto an arc that is 106 degrees plus some. So if 93 is going to open up onto an arc, 93 is an inscribed angle, so we're going to double it. We're going to get 186. So if this arc is 186 from Y to X, then it's going to be 106 over here and 80 for this arc. Okay, we know this arc is 80 because 93 times 2 is 186, and we've got 106 and 80. All right, so now we need two more here, and let me think about how I might go about finding these. Well, I know that this arc is going to be the remainder of the circle. So if I have a 360 degree circle, then I can say that I can do 360 minus 58 minus 106 minus 80, and I can get this measurement over here because that's going to be the remainder of those degrees. So that's going to be 116 degrees out of the 360 degrees in my circle. Now that I have all the arcs, I can get the rest of the angles pretty easily. So here in Y is an inscribed angle that opens up onto an arc of 116 and 80. So that would be 196. I don't know what I'm thinking. So if 196 is the arc that Y opens up on, Y is going to be half of 196, which is 98 degrees. And then we've got one more, and we can do this either by adding 116 and 58 and dividing by 2, or we can say that we have a quadrilateral in here. And one thing we should know about quadrilaterals is that all quadrilaterals add to 360 degrees. So we could do 360 minus 82 minus 93 minus 98 to get angle Z. And so angle Z is 87. And then we can check to see that we're right by going through here and saying, well, if I have 87 times 2, I have 174. And it's 116 plus 58, 174? It is. So that must be the right answer. All right, you've got lots of practice problems to do with angle and arc theorems for these first couple of elements of section 10.5. And then tomorrow we'll do the rest. All right, good luck.